All right, we're ready to get started this morning. Our topic this morning is CAM350 and DFMStream. Specifically, we're going to take our first look at version 14.6, which was released a couple weeks ago. Some enhancements in that, some further enhancements to things we've already started working on with 14.5. And then we'll also just take a general look at the analysis capabilities of the tool. So in just a quick list, actually I'll take it from the release notes here. These are the new functionality that you will see in the tool. So if you download the latest version, go ahead and take a look at the release notes as well. They'll actually help you because there's some instructions on how to use some of the features in there. So yeah, take a look at those when you download version 14.6. Let's take a look at the major enhancements, and I'll demo quite a few of these. First of all, we've gotten to a Visual Basic type of API for writing your own scripts that go along with the tool, and we've gradually phased out the old macro language. Now, that's not to say that your old macros won't run. We have allowed the old basic-based macros to still be run in the tool. Now, you might run into issues where some commands have been replaced, but for the most part, they should run, and our tech support can help you if you do have issues with that, but hopefully you'll move to the new VB scripting. And one of the things we did is we included a record and playback option. And what that allows you to do is record what you're doing on the screen and then play that back and then use that to help you write your VB script. One of the things you can do is you can actually record an old basic script and then play it back using the VB capabilities. So again, enhancing that capability to run older scripts while giving you the power of a more current and a more generic, if you will, scripting language in Visual Basic versus our heavily customized basic language that we were using in older versions. We've added some new DFM analysis specifically for rigid flex, but they could be used on other just on rigid designs as well. And we'll take a look at those. A smaller enhancement, net bridge support. We go back to the days where you would send over an IPC netlist and I'd run the comparison in the fab shop and I would see the digital and analog ground were shorted together and I would put the job on hold and get back with you and you'd say, well, yeah, I intended to do that. And then hopefully somewhere along the way you've added a print note or a README note that says that you intended to do that. Well, in this release you can actually tell the software that it's a net bridge, that's an intentional net bridge, and therefore it will not call it out as an error. We'll talk a little bit more about that in a bit. Support for IPC 2581 Revision C. The main topics there, of course, are flex, rigid flex, and embedded designs, and now we are fully supporting those with the inclusion of Rev C support. And right along with it, that expanded support for rigid flex layer types. We've added a few more with this release, different things that may not have been in the original. I think Shield was one we added in this release, and there might be a few others. And then for those of you that are doing large layer counts or designs that have a lot of graphics, this last one should help you significantly, as we have updated our graphical interface to support what's called OpenGL. We used an old type of graphical interface, and we've used it probably for the last 25 years, which caused issues on large designs, redraws, things like that. Were slow, even though the horsepower of the machines is a lot more powerful. You would still run into this. The OpenGL, in a lot of cases, has really, really enhanced that. Redraws that used to take 10, 15 seconds are now instantaneous. Where you're going to see this the most is on large designs. I will caution you on that, and that's a good place to start here as we go through these items, that because it is a new interface, you may run into issues. We've done extensive testing. As a matter of fact, I was kind of doing a lot of that myself before this release and testing different functions and how those reacted to the OpenGL. We left the icon in here, which we used for testing. We could flip it on and off. And I would say if you do run into an issue, go ahead and try turning this off and see if that changes anything. And it can be as simple as things not looking correctly. That is something we're going to leave in the tool. But it should, the OpenGL itself should really enhance the tool and its speed. All right, so I started off here in the 3D. I just wanted to kind of show how that looks in 3D, and now we do have a shield in there as well, and a stiffener, I believe, and maybe a couple stiffeners, I think. Yeah. Anyway, we've updated our demo board here to show that. What I'm going to do now, though, is I'm actually going to move back over into the 2D world, and we're going to talk a little bit about the VB capabilities in this release. So, under the Home ribbon, you will see the script editor and the script recorder. A little information about the script editor. This is just a standard script editor. This is nothing we've created. This is something readily available for people who are writing scripts and want to play them back and debug scripts. Along with that, we've included a recording function. So if you do something as simple as, I don't know, let's go in here and if I wanted to record a function, whether it be something like just deleting something or something like that, what I can do is hit record, give it a name, save it, and now you get this little recording icon over here that indicates that you are recording. I'm going to perform the function. Okay, and we've deleted a trace. I'm going to stop the recording. And now we've recorded what function I did there in a script. If I go to the script editor, I can actually open up that script that we've just created. And let's take a look at it here, make this a little bit bigger. A lot of it is just environment. So it takes a picture of the environment before we do that, and that's what a lot of this stuff is. And then you see I turned off the grid snap here, and then I turned on edit delete, and I selected a single item, and then we went ahead and then I did a redraw on that. So basically that's what's in the script. If I were to play it back, it would just simply go through and I'd put the trace back. It would simply go through and actually, let's see if we can do that. And run the script. So I've put that back with an undo, and we'll just go through here and make sure we have that open again. And run the script. Okay. So The idea being, you know, of course, we're not putting dialogues and things like that in there. We're putting the screen actions or the actions that you're doing in the tool in there. And then the idea is that you would have some knowledge of Visual Basic Scripting, write your own forms and so forth to go along with whatever function you wanted to do here. One of the ones I have here, and I don't have it quite ready for prime time yet, but it opens CAM350, loads a checklist, runs it, then closes CAM350 and saves it, and then the user can open that up in either CAM350 or CAMView and then validate the results. So it does it all without a lot of interaction to the user. Now, I would probably suggest that there's not a lot of interaction, but there are some people that like doing it this way, so certainly it's something you could write and use. Quite frankly, it's only about 5 mouse clicks to do that anyway. But we do get that request a lot. People want to run analysis without spending a lot of time in the tool itself. So it is VB, and there is an API. If you go to the help system here in the script editor, you'll get the API documentation. Which has examples, it talks about various functions, and it talks about how to go ahead and run scripts inside of our tool. Okay. So that is an overview, or a simple overview of the new Visual Basic API in our tool. The next thing I want to talk about is the new DFF or DFM that we've included for this release. Now, what we did in the previous release is we put our support in here for rigid flex designs. And in doing that, we added concepts to the stack-up visualizer, so no longer do you have just one generic stack-up. You might have one for a rigid area, various rigid areas, various flex areas, and all of those, of course, can be modified. You can change the dielectrics and so forth, and you can even import and export those. So there are many tools now that do support this. On the CAD side, I know that the Cadence tools support it. I've heard that the Expedition tools, I do not have a copy of Expedition, so I can't verify that, support it. Polar supports it on the impedance side, and a lot of our competitors hopefully support it as well. And the idea being that instead of creating a stack up your AE at the fabricator and sending a picture of it back to you and saying, hey, this is what we need to do to get 50 ohms, you can actually, he can send you the stack up, and you can import that either into your CAM tool, your CAD tool, or even your documentation tool if you have a tool like Blueprint, and then put that down onto a document that shows that stack up. So we can both import and export that stack up. It's in a generic format. The format just happens to be the IPC 2581 format. Okay. Along with that idea, we also enhanced areas in the last release so that not only are we doing areas of the design for rule areas, we have different types of areas, and one of those might be stack-up zones. So each of those stack-ups that I looked at are in a specific area in this design. So those define the zones for those stack-ups. Each layer might have its own profile, so that you're showing that area. In this case, what I call the chest area here, of our little stick man. And that is our rigid A area. Our rigid B area is over on the sides here. So these correspond to different stack-ups, and they are different portions of the board. Now, connecting these, of course, are a flex area. But the problem is you can't have data going between these from the rigid areas. You would need a layer that is included in all of these in order to have traces, going across these. So we have that idea as well. And we look for that in DFF, which we will here in a second, to make sure we don't have traces leaving their various areas or various stack-up areas. So that was included in 14.5 as well. What I'm going to do now is just go and take a look at these new DFF analysis that we've added that take advantage of this idea that we have stack-up zones and areas. And the first one is rigid flex analysis. Now, we call these constraint panes internally, but basically they're the ability to run a particular type of analysis just on its own without running a checklist of everything. So if I enable all of these, I could go out and run this analysis, and it's going to come back and give me any failures. Now, just quickly through these, I'm not going to spend a lot of time talking about each one, but they're pretty standard checks for flex and rigid flex designs. We worked with our customers, both OEMs and our board shops that are doing these types of designs, and tried to get the biggest bang for the buck, to use a term. These are the ones we put in with our initial release. The idea being that there will be a follow-on release as we get feedback from you and from other users, misses or things that cause problems that you want to look for, and we'll add to this list, and it's already being worked on and spec'd out right now. So, missing cover lays for various types of elements, slivers of cover lays or data outside the stack-up zones, things I was talking about earlier, looking for either rounded corners for items to make sure that they're rounded or not in some cases, trace corners, looking for those, make sure we don't have those in bend areas. In a bend area, you don't really want solid copper. You would probably rather have some sort of a grid, so we're looking for solid copper in a bend area. You think about it, that's going to be more brittle and harder to bend versus a pattern of some sort. You don't want vias in bend areas in a lot of cases, and you want to make sure that traces are perpendicular to the axis that you're bending. Okay. All right, so these are some of the checks: cover lay spacing, cover lay to track, cover lay to pad, cover lay to copper, cover lay to cover lay. All of these can be set up and run, and we'll run these in just a second, but I just wanted to show them in the constraints panes here. And along with that, we added what we call interlayer, not interlayer, interlayer checks. And we gave the user the ability to create their own. So we did this with rigid flex in mind. So there's various types of checks that you can run: a gap, an overlap, an annular ring, the minimum to a gap, exposure or partial exposure, and then slivers of various types. These are the types of checks, but you decide how you want to run it. So for instance, this first one is looking at the top cover lay to a solder mask layer, okay, with a value in there. There's some additional ones from the top cover lay to a solder mask layer, or a stiffener to a shield. You want it to overlap or not overlap. You can even invert. So if the layer that you want to compare to is positive, and in order to compare it, you need it to be negative, you can hit the invert function here. Okay, and you can run it on different types of constructs, whether they be draws or flashes. And again, once you've created a constraint, you could add it to this list and save those and rerun design to design. Now that is dependent upon layer names, as you can see here, so that may not be something that gets transferred unless you have a standard naming convention. You can also save as default so that those values are always in here. But one thing that you might want to do is save it to a stream, and that's our checklist. And if those of you that are familiar with our checklist, it is layer-based typically, but what we can do is we can add these interlayer checks to that stream, and we can create a new stream or a new checklist, or save it to one we have open. And I'm just going to save it to our default one here, and you can rename it as well if you want to. I'm also going to add the rigid flex checks to our checklist, and I'm going to do that a little bit different. I could have done it the same way, but I'm going to bring up the streams editor and show you a different way that you can add these to them. So I have my streams check here, and I want to add the rigid flex checks to it, and it's going to use those default values and plug all those in for me. As always, when I'm ready to run analysis, I have options. I want to run it on everything. Do I want to run it inside the board outline, or just select an area to run it in? I'm going to run it inside the board outline because I don't want it to catch this text out here as an error. Obviously, that's something like title blocks or crop marks or something like that that you don't want to run analysis on. And that's always been in there, the option to run only in a selected area. For those of you that aren't familiar with our analysis, our checklist-based analysis, we do a little bit of cleanup on the design first. We expose this to you. We show it to you. Other tools out there do this in the background and don't give you the option to turn them on or off, but we do our cleanup, and you can choose which of these items that you want to do in the cleanup algorithm. We have customers that don't do any of them, but it's generally going to limit the amount of false errors that you get, so I do highly recommend including that. Then you go to different layer types. Now I've split off internals and outer layers because I have different parameters for each. Okay, and that actually follows along with the IPC specifications. So you don't have to do it that way, but you certainly can. We have negative plane checks that are specific to negative planes. If you're not doing negative planes, you don't have to include it, or you can include it, and if it never sees a negative plane, it just doesn't run the check. These are set up to be generic. As a matter of fact, this checklist itself ships with the product. This came from a major board manufacturer. It's one of their facility's minimum requirements. So it's a good starting point if you want to start modifying these parameters to what you do internally or what your board shop does. And it's as easy as selecting the parameter to change it. You don't have to go off to a third-party tool like some tools make you do. And when you do make changes in here, we give you some options on how you make changes. Like if you wanted to change drill space, and you see I've got different values there, I could go to drill spacing over here and change them all at one time to a certain value if I wanted to, or do individual values. So I got the spreadsheet mode or the matrix mode, as I like to call this over here. Underneath all this is filtering, so you can filter in and out by decode, layers, areas, NC tools, NC layers, and filter those in and out when running analysis as well. So very robust ability to run the analysis. Let's go to solder mask. These are specific to solder mask layers, silkscreen, drill and mill, paste masks. We'll even, if you are creating your own paste mask or stencils, we can even do the ratio checks, the IPC ratio checks. Here's where we added our inter-layer checks, and here's our rigid flex checks. So all of those can be just kicked off, run, and then you validate the results once it's done. And as I mentioned before, if you really wanted to take that further, you could record a script that runs this particular checklist and then saves the design, and then you open it up at your leisure and go through the results, which is what I'm going to do now. Okay, so that is the streams checklist, but before we get out of this and go to the results, I want to show you the constraints pane. So, you know, when I'm on cleanup, you see this dialog here. I could actually run the cleanup, just the cleanup by itself. Or if I wanted to run an annular ring check, for instance. Now there's annular ring checks in both the internals and in the, so here's my annular ring checks, in the internals and in the outer layer parts of my checklist over here. But if I just wanted to run annular ring, I can always just do it on its own. And if I like the values that I ran when I ran annular ring, I can always save those to a stream, which is what this is, or I could just make these the default for this particular constraint pane. Excuse me. So again, the difference being, here's a checklist, and actually the total number, we're approaching 150 different DFF rules that will run on a particular design now. And then those are either broken down by layer types here for the most part, or by individual types of checks. So, you know, I mentioned the negative planes. Here's all those negative plane checks. Or if you just wanted to make sure you're not putting silkscreen on solderable areas, you could just turn on this one check and run it and just check that analysis. So again, pretty robust in how we allow you to define the analysis that you're going to run on a design. When we went to 14.x, we split off the analysis from the results. It used to come up in its own dialog. Now that comes up in the Air Explorer, and any analysis you might run on a design shows up in the Air Explorer down here. I know a lot of people, when they first got 14.x, kind of got rid of these. You can always bring them back under View and Panes. And you can turn these on or off. You may notice I have the world view turned off. You may like that. I don't, so I don't use it. It's up to you. The selection filter over here is actually set up to be auto hidden. And if I move my mouse over here, it shows up, and I could pin it so that it's always there if that's what I want. Any of these panes can be picked up and moved off to another monitor, and it will remember that the next time you open the tool. So again, trying to give you a robust environment for both doing analysis and then validating the results of an analysis. Clicking on an error, takes you to that error just as it always has. We can even do 3D, probably not the best example, but you can go in here and look at some of these errors in the 3D mode and see if it's additional information, you know, 2D versus 3D, it's up to you. I use the 3D a little bit, not entirely, but you can certainly use that as an option. So again, this was a board outline to copper check, and it fell below the parameter of 254, and it was 1467 was the actual value. As always in our tool, you can create an error chart, and I could reduce the granularity and maybe end up with more than one bar here if I wanted to, is split these up. I'm just going to leave it the way it is for now. If you are okay with this, you can select them all, first of all, and it'll highlight them all. You can kind of see them all here. And you can right-click on them and say validate those. So that means you've gone through it, and you've run the analysis, and you decided those are okay. But maybe one of these isn't okay. You know, if I go to this one, for instance, and I decide, you know what, I need to actually either move this trace or, you know, change the board edge. So I'm going to add a note that says that. I say okay to that, and now that note is attached to this particular error. In addition, you know, all the rest of them are validated. I could actually hide the validated ones, so now the only thing it shows in there is the one that I have an issue with. What I'm going to do is actually do a save as here. And let's put this out on the desktop, and we'll call it Wednesday. And then I'm going to use our free database viewer. If you're not familiar with this, we have a free database viewer that anybody can download from our website. It's called CAMView. I think I'm a couple revs behind here. Hopefully that won't cause an issue, but CAMView can open up any CAM350 database, and it has some nice functionality built into it. First of all is I was validating these failures inside of CAM350. Well, what if the guy next to me or gal next to me needs to use CAM350? Well, if we only have one license, they can't. They have to wait till I'm done. What CAMView does is it allows you to validate the results of your analysis without taking a CAM350 license up. So I'm just going to open up that same design. It'll tell us that it's already open. Generally, you're not going to have it both places. And now it's going to load up that particular design in CAMView with all these errors. Again, I could choose that option to hide anything that's validated. And again, there's my one error with the notes. Now, this could be me feeding back to a designer, and all they would have to do is open up the CAM350 file. Then all that information could be in there. And whether I'm a fabricator or somebody just tasked with doing analysis on designs before releasing them to manufacturing, again, I can feed that information back. I can even add notes in CAMView. So if I wanted to, for instance, change that, I could say done. And when I exit CAMView, it's going to prompt me to save this, realizing that something has changed in here. Or it could be as simple as I went in and I validated something else. Again, that can be saved from CAMView. Okay. And then the last thing we did with CAMView is we give you the ability to cross-probe. So if you're a user of any of these CAD tools, you can be looking at the error here in CAM350 or CAMView as well as in your CAD tool at the same time. It'll search for the proper layers, the proper location, turn those items on in your CAD tool. Now that's not always as easy as it sounds in a CAD tool because a CAD tool is looking at things like pad stacks and entire design at one time, whereas analysis tends to be more of a two-dimensional analysis inside of the CAM350. Of course, with our interlayer checks, now we do it more of a three-dimensional type of analysis as well. Anyway, that's CAMView. I did want to show that along with our CAM350, and there's where it says, and prompt me to save. I'm not going to save, and let's go back over here to CAM350. So we do get the requests from time to time, and if you got $30,000, $40,000, $50,000 hanging around, there are some expensive tools out there that create an HTML version of the errors. This is our answer to that without having to charge you that much money. Okay. All right. Again, going through these checks, let's take a look at the rigid flex checks here, and let's see, profile to track. So these are those layer profiles. This is one, and this is another, and I got a trace going through both of them. Well, that doesn't work. Okay, so that's why that's called out as an error. Some cover lay to solder mask issues, or cover lay to silkscreen issues, similar to a solder mask to silkscreen issue. Data outside of stack-up zones, we've already seen some examples of that. Here's some more. You can't really have data outside these zones because they don't exist. If that was on my flex layers, yes, but not on my my rigid layers. And then cover lay size, trace corners is a good one. You do not want those in a bend area. So these are bend to trace corner. And here's our solid copper check. There's that solid copper is the this color blue here. And it's basically telling us that, hey, you got solid copper in a bend area. That is not something you want. Trace is not perpendicular. As you can see, they're going diagonally through those areas. And then some trace corners that are adjacent to bend areas as well. Again, these are all things that can go wrong with a rigid flex design, and we've included those analyses in here. I'm going to go to my interlayer checks, and again, you can see we have some failures here. It all depends on what you were trying to look for here. This looks like a layer-to-layer from a solder mask layer to a cover lay layer. And you have the parameter there. It failed the parameter, and it's giving you what the actual distance was. Layer to cover lay opening. This is kind of a sliver check. Again, I think this is very similar to what we found in the rigid flex checks. Layer to layer, partial exposure of something. Some annular ring. Okay. And these are all different types, again, of checks that are specific to rigid flex. Now, if I go to some of the more standard or more rigid types of errors, I can see things like mask slivers, if I'm looking for slivers between mask items. Annular ring, if there's anything, looks like it got some solder surface mount annular ring issues. I think they're actually one-to-one in this case. Silk screen, yeah, we are putting some silk screen on some solderable areas, and it'll call those out. And then more of your standard copper type checks. Okay, so all told, again, we can do about 150 different types of checks, and we will report those back to you in the tool. All right. So again, we're kind of going through 14.6 as well as talking about issues that were addressed in 14.5 or enhancements in 14.5 and 14.6. I really don't have a good example of where OpenGL, speeds things up. I need to get a really complex design from somebody for that. But just be aware that you can turn it on or off. You will notice a little bit of a dimming there as I do turn it on or off. Again, that is something that should really speed up things like redraws on complex designs. All right, with about 15 minutes left, I'm going to just kind of transition to a standard design because I just want to show you some of the standard features for those of you that are new to the tool. So we'll just get rid of that, and we'll bring up our other demo board. And I'm going to import that via, I can either bring in Gerber and NC, or I can bring in ODB++ or IPC 2581. For our purposes, I'm going to bring in 2581. I'm going to go to 3D real quick just to show you that because it was an intelligent format, we can actually extrapolate the components as well as the layer data from the component outline and the height information here. Okay. And you can split layers apart. You're probably familiar with most 3D tools and how those work. You can split and peel off layers and so forth, and zoom in and pan around or cut into the design. This 3D capability is in all of our tools. So everything from the free CAM350 viewer that views CAM350 databases to our highest level of blueprint all have 3D capabilities built into them. All right. So anyway, back to our design here. A couple of items, things that have been enhanced over the years. Number one being the tooltips. So if I just put my mouse over an item, it tells me what it is. I no longer have to hit query and then click on an item to see what it is. I can just simply put the mouse over an item and it tells me what that particular item is. We will also superimpose information if you like. So if I go to View and I go to decodes, for instance, it actually superimposes the decode number on top of all of my features here. And this could be useful if you're doing editing. We all like to think that board shops don't edit designs, but we all know they do. Having spent many, many years in board shops, I know that we did on every design we ever had. So if you think they're not editing your design, you're mistaken. But that's one of the things you can do is turn on decodes. If you have intelligent data, you can actually turn on the pin numbers, and it'll show you the pin numbers. And we'll even show you the net names. So as you're scrolling around here, you can see that these are your impedance traces, and maybe you have a diff pair or something like that. It's an easy way to go and look for those. There is a find functionality where you can actually go out and look for particular nets or reference designators for intelligent data and find those. But there's also a table for that, and quite frankly, I use the tables. So external nets, if they're present, this particular design doesn't have them, but most do, would be your intelligent net names, these names here. And then your nets typically are the Gerber extracted, where we just put a number on them. Either is acceptable, but you probably want these more intelligent names as you're looking at the data. Okay, so those are some of the viewing options that we put in here with this release. Another one that I like is, and we get this request all the time, is, hey, I'm seeing these component outlines and I don't want to see them. Well, you had to go to options previously to turn those on or off. Now they're just right here. We moved that out here. NC tool colors when you're working on NC. So there's some things that you had to push into the tool in different areas to turn on or off, and we've added those to the view ribbon now, just to make it easier. All right, a couple other features under analysis that I want to show you. First of all, I'm going to just save this to our desktop, and I think I'll just overwrite our existing Wednesday.cam. And then I'm just going to go in and make a couple quick edits here. It is a fully functioning CAM tool. You can create a lot of havoc with it if you want to. I'm just going to create 3 different types of differences here. And let's add something here, maybe to the bottom. Let's see. Why don't we add a trace here from there to there. All right, so now we definitely have some differences here. So this is my Rev B. Okay, and if I go to Analyze and Design Compare, I can load up Rev A and see what the differences are. So I'm going to load up Rev A. It'll load it up here. If it's not registered, since it's a graphical comparison, they need to be in the same location. If it's not registered, you'll see a difference here. If it is registered, you can just go simply to run it. There are some parameters that you can put in, and you can also map the layers here. So if your layers were not mapped automatically, you can manually map those layers. We do it by layer name. One thing I was working on with a customer yesterday is they want to compare their panelized tool data to the original Gerbers they sent to their fabricator. Well, one of the options here is to either run inside the board outline, so I could define the board outline and it only runs in that area, or in a selected area, and I can actually select an area to run the analysis. So I could have one of my designs be 1 up and the other design, be Gerbers that are 16 up, but still do that comparison in that regard. And when I'm ready to run it, I just say go ahead and run, and it goes through and compares all the layers. Now, looks like there's 22 layers there, and it went through and compared them all, and it's going to show us, just like everything else, what the differences are, and we can see any differences between those. Okay. All right. Oh, by the way, when you're done running the analysis, you can always hit Delete Imported Design, and it'll remove that second design from your current job that's loaded. So that is Design Compare. And lastly, I want to show you one more thing under here, and then I'm going to leave it open to questions. If you do have questions, please type those in. But we have another feature called the Design Analyzer. And it's a somewhat confusing name in that, that's all we're doing here is design analysis. But the idea behind the Design Analyzer was that originally we just wanted to extract the minimums for creating quotes. Well, that was useful for the fabricator, but not so useful for the designer. So while it created this nice report, with minimum line width, space, annular ring, copper to whole barrel, and so forth, the designer wanted more to use this. So what we did is we give you the ability to put in your vendor's capabilities. So if I'm using a couple different board shops, or maybe 20 board shops, I can put their capabilities in here, and it's going to compare those minimums once it extracts them to the board shop and let us know if they can build it. So I just simply hit Analyze the Vendors. It extracts all those minimums and then compares it to my 2 board shops here, and it's going to tell me whether they can build it with a checkbox or check mark or an X. You could also use this for volume versus prototype. You could have prototype numbers in there versus volume numbers and have it extract that as well. And as always, there still is a report that you can create from this, either an HTML-based report or a CSV, or a kind of a spreadsheet type report if you want to suck it into a different tool. Like I know some people are bringing it into their planning tool and pull that information directly in. So that is the design analyzer. All right. Leave it open to questions at this point. Our purpose this morning was to introduce you to the tool, show you the new features in 14.6, and recap 14.5 and earlier 14.x with our new graphical interface. If you are moving from an older version, I can't stress this enough, File, Help, CAM350 menu map. So this is where it was in 12.2 and earlier, when we had more of a toolbar-based menu tree. And then this is where it is in 14.x and later with a ribbon-based graphical interface. So this can help. You can print this to PDF or print it out. There are many tutorials in here. There's a rigid flex, there's a CAM editor, there's a panel editor, there's IPC netlist. All of those can be accessed from the help system, or if you're out here on the start tab and you want to see the CAM editor tutorial, it'll take you right back there and you can go through this. If you are new to the tool, if you're evaluating the tool, I highly, highly recommend this. Just going through this. This will get you up and going on the tool much quicker than me showing you or tech support showing you. And it's honestly the basis of our training class when we were out and doing those out in the real world here pre-COVID. So I do encourage that. We've added this rigid flex. That's been enhanced with this new release. And as you saw, there's some additional ones in the help system as well. Okay. We also have a YouTube site that shows a lot of these features and functionality. I don't have any of the 14.6 ones out there yet. That's my project for the next few weeks, is getting those out, and those will be available as well as the other 100 videos that we have here on various parts of the tool. I don't see any questions, so I am going to go ahead and close it down. If you do have a question after the fact, send it over, support@downstreamtech.com or rayaf@downstreamtech.com, and we'll answer those. And if we need to get on one of these webinars, we can always do that. And I know some of you are in different countries, so we do have reps in most areas that can walk you through this as well. I want to thank everybody for your time this morning or afternoon if you are over in Europe or further east than Europe. We do these monthly, and we'll be repeating this quite a bit. And actually, I have recorded this particular one, and I'll probably be putting this on our YouTube site as well. Thanks, everybody, for your time this morning.